So I'll talk now about Surrey and what we're doing for our climate project. Just so you get a better perspective, I know some of the other ones had pictures of Surrey on them, but you can see Surrey is when you cross the US border, you're in Surrey on your way to Vancouver. Most of you probably think of us as a farmland when you come across, if you even think that we're Surrey. You see the nice mud flats as you're going down the highway towards Vancouver. That's a part of Surrey. We do have urban parts of Surrey too. But a lot of us, what I think a lot of people see in Surrey is actually the farmland. We're actually 500,000 residents strong, and we're growing at about 1,000 people a month. When I started at Surrey 16 years ago, we were 200,000 people. So it's quickly moving. Surrey's actually developing quite quickly, as is Vancouver is densifying quite quickly. Of that, we have 54 kilometers of shoreline in Surrey, of which 22 kilometers along the Fraser. We have 100 kilometers of dikes. On the earlier pictures that Thomas was showing, he was actually only showing the sea dikes in that picture. We have extensive river dike systems too in Surrey. A lot of the studies to date from the provincial level have been great on the sea level rise, but they haven't actually allowed or taken it back to the river systems for people like ourselves who have extensive rivers connected to those sea things. So a lot of Surrey was developed by the farmers who expanded, like put the dikes in, put sea dams in to reclaim the land for agriculture. So a lot of the areas we have, especially in the middle here, is actually farmland. A lot of it's in our agricultural land reserve, which makes it really hard for anybody to change it from agricultural purposes. And then also we have different restrictions. We actually have different bylaws and stuff that make a lot of our floodplains stay agriculture, which helps us in a different way than Vancouver. We have not developed to the density in our floodplains, but we're still vulnerable. We still have people living in them and infrastructure in them. On the Fraser River dikes, that is heavy industrial. We have its major transportation corridor. When you do see our agricultural areas, one of the key things across our agricultural areas is the transportation routes to take the goods to the port facilities. We always joke about with the coal now. So if we flood the Surrey lowlands, there's no more coal coming from the States to Canada. It's that. We're dealing with port activities, really from the transportation, and also people trying to come into Vancouver and stuff. The climate change impacts. We've got different strategies that'll affect social, everything. I've brought a copy of our recently adopted climate change adaptation policy. It has our adaptation and our energy emission things that was recently adopted by council. In the strategy, when we developed these strategies for the city, it wasn't just looking at one facet like sea level rise or anything. It's kind of similar. Vancouver did very similar. It's looking at the whole suite, looking at the heat issue, looking at the change in vegetation. One of the big things that came out of our strategy, we've also adopted very recently a biodiversity adaptation policy in Surrey. So we now have a biodiversity strategy in the city too, and looking at how we build to that, looking at how we maintain that. And all the different departments are involved. So we had quite a few different sections, developing that document, buying into the document. We looked at the 6 main sectors. It always comes out, floodplains, flood hazards always come out as a big one. Infrastructure utilities, again, with how are we going to be vulnerable in the future? Health and safety of our citizens, our ecosystems, urban trees. Agriculture is a big one in Surrey. A third of that floodplain is agriculture. A third of all land in Surrey is agricultural based. That is a huge portion of the food production for the greater Vancouver area. What does that mean? Other communities are very similar to us, like Delta and Richmond. Big parts of the food production for the Lower Mainland is in these vulnerable floodplain areas. From our strategy, we came out with 91 actions, which is kind of daunting when you go through the list. And then we kind of we figured, okay, let's pick top 10. And a lot of them we're already working on. Like I said, the biodiversity strategy, the education of climate change, doing more field data, doing some of our tree work, doing our floodplain work. We have our strategy, we're also updating our official community plan. So in our official community plan with the update, we've brought our energy strategy and everything into the plan, but we've also brought in development permit areas specific for hazards. So flood hazards and land hazards, so slope hazards, on these sites as a way that we can control who and how they build in vulnerable areas. So it was trying to get the picture of, you just can't build any old way you want to build down there. One, you're going to know that you're in a vulnerable area when you're building, and two, you're going to be building special ways so that you have the resiliency in case of an event that happens. In 2008, Council also made a key policy at that time. A lot of the fringe land at the base of the slopes, it's kind of on the cusp of your floodplain, a little bit in the floodplain, was not in ALR designation. It was actually in urban designations. And we've actually said you cannot rezone this land to a higher density use because we do not want population into these areas, because we know that if we allow them there now, we're going to have to be doing flood works for them in 50 years, and that's really it's not good. It's not good. It's going to cost the taxpayers a huge amount of money. We're not sterilizing their land. They can still build. They can still build their house on it. They just can't change their land use to a higher density. That's just on our flood fringe areas. A lot of Surrey is high enough. We don't have to worry about that. But this is one of the things in our current, when you're rebuilding in a floodplain right now, in one of our floodplains, you're not allowed to rebuild to the elevation you were in the past. You are now rebuilding to flood construction elevation. Your first floor, your first habitable floor is at the flood construction elevation, whether you're diked or not. So whether there's any protection for floods in this area, you are still higher in the new thing. And people are doing it. Land values, especially, this is in our Bridgeview part of town, land values are such that they're so expensive that people are going, okay, we'll do it. Our planning people have had a bit of a challenge with the zoning and the height restrictions and things like that. They've had to relax them a bit in these areas. But here just gives you an example. I'm not talking 1 meter up. We're talking 3 meters up. We're talking 4 meters higher than the existing ground. A lot of the lands behind the dikes, some of them are currently at 0 or 1 meter. Some of our floodplains are required to go up to 5 to 6 meters. So it's quite a substantial difference. You can't necessarily preload these lands or fill these lands, one, because of your existing utilities, and they're also soft soils. So if you don't have a big enough base, if you preload it too much, you're actually failing your neighbor's house. So it's very tenuous to actually build on some of these lands, and we're not sterilizing the lot. You can rebuild a house, you just have to rebuild it so it's smarter. You just have to rebuild it so if a flood does come, you're protected. And other places too, we're looking at rebuilding some of our infrastructure. So now that you're saying, how do you rebuild your infrastructure thinking it's 100 years? We did a climate study in the Crescent Beach area, and we found that our dikes are high enough for now, great, but they were getting back flooding. Groundwater has come up. The groundwater levels behind the dikes are now totally tied into the tide because it's a sand-based area. So we don't have the attenuation the same. So even though your dikes are really great protection, the groundwater in the city's up higher. This actually part of town, we didn't even have many pipes before because the sand was so great, it would just all go in the ground. We didn't need the pipes. Now we do. So now we're bringing in a drainage system to the city. We built a pump station. My pump station's life cycle is 80 years usually about. So I didn't build this for the 21, we built it close to the 21 condition, understanding that in 2100, I'm rebuilding the station or I'm adjusting the station. So we built this thing with that in mind. I can move the electrical, the electrical controls are high enough, but I can move some of the pump settings up as I need them. So you build that in to your design as you're doing the design. You have to build for now, but you got to think about what's it going to look like in 50 years, what's it going to look like 100, how can I build it in stages? It's not good to build automatically for the 100 year because you're not going to get the life out of it. You're not going to need it, especially if you have a rebuild in a few years. The other thing Thomas talked about was subsidence. It's really a mystery. Everybody knows the area is subsiding. You don't know the value. We've taken the research a little bit further in Surrey to look at what is the variability of subsidence. How is it going to affect different areas? There's one area that actually may become a trapped lake it's subsiding so much in the north, but the river's kind of bouncing up, but lowering in another part. Are we going to get a confined lake there? Do we have to look at the hydraulics of how the river moves? We've looked at our rainfall trending. We've looked at, and we found that, and we've redone our IDF curves. We just haven't had the guts to publish them right now. But some of the rainfall periods, 44% higher. And that's just looking at historic. That's just redoing them based on all the historic data. Because it hadn't been done for about 10 or 12 years and inputting some of the gaps. We're also looking at our flow monitoring stations, our water quality, looking at the changes in water quality, looking at the changes in salinity, looking at with the biodiversity, looking at the changes of the species. So I found it really interesting to see all that information over that I'm going to steal into those websites when we're looking at our biodiversity, when we're looking at what street trees should we be planting that are going to live in 50 years. Because we want to plant them now, the right species or the right divergence of species. So we're looking at all those kind of things. And also planned research. We've got to do a little bit more on our waves and our coastal. We've done quite a bit of research, but we're probably going to put a buoy out in the coast just to get a better idea. And a lot of different local communities, I think Vancouver put a buoy out too, is we're having to do it ourselves to get the information we need. The global stuff, the regional stuff is too big. We need more local. And so a lot of us are augmenting that information with our own data, our own equipment, so that we can get the answers we need to do the protection we need. One of the big studies we did was on the Serpentine, Nikomek, and Campbell rivers. So this is where we have the sea level, we have the sea dikes, and we have the rivers behind. And everybody's so focused on the coast, but they're not focused on what is this going to do inland to the rivers. Our rivers are almost, well, I'll show you the results in a bit, but they go through Surrey into other municipalities upstream of us. So our first phase of the project, Northwest Hydraulics, worked on that. I think they're here. Yes, they are. And they looked at the coastal focus. What do I have in my coastal? What's my vulnerability coastal? What will my potential effects be up the rivers? And it was kind of our first kick at this whole thing. We had a lot of questions on subsidence. We hadn't done our subsidence work. We hadn't done anything on climate change either in terms of rainfall. We were just assuming status quo for rainfall. And we got some numbers. And they were pretty scary numbers. And now in our phase 2 of the study that's underway with Northwest Hydraulics again, we're looking at sensitivities to climate change in terms of rainfall precipitation. Like, what is the sensitivity to our river systems to these? Like, not only do we have sea level rise, but if I have changing rainfall too, what's that going to do? The rivers are especially sensitive. Part of the rivers are more coastal driven, part are joint coastal and rainfall driven, and then the upper parts are more rainfall driven. How is that wedge going to change? How is the sensitivity going to change in those? And then also the cost benefit. So these were the phase 1 results. You can see that the change in the bottom is meters, but you're looking at almost 20 meters upstream of our sea dams will be the impact from sea level rise on both the river systems. That's huge. That's almost to our neighbor's border. And it's not a little difference. It's over a meter difference all the way up our river systems, which means you're going to be changing how you even do your urban development servicing to some of these systems. The impacts we found by 2100, we're going to have our 200-year storms at the sea dams are going to be less than 2-year returns. All our coastal dikes are too low, some needing 3 meters or higher to go up. Our river dikes need to be assessed more fully. We're doing part of that. Of the 13 bridges, basically 10 are going to be affected and they haven't been designed for it. We had done this for a study last year. The lower bar you see is actually current value we should be at. The upper bar is actually with 2100 sea level rise. We didn't do a 2200. We were just looking at the 2100. And these are different coastal things, different exposures. And you know, you're looking at this and going, okay, I can raise a dike there. That's not that bad. You know, those people first floor can't see anything, but it doesn't look that bad. Then we get into the extreme ones. Soft soils, I can't raise a dike these ways. How are we going to do it? Now do we start getting into things such as, okay, we need a breakwater to cut off the waves, so that cuts it down a meter. Do we need, you know, you got to look at some of the bigger strategies now. Or do we retreat? Retreat is always an option on this, but then what's the value of the agriculture in the area retreating? And also the fact the retreat area has one of the major highways and one of the main railways into the ports and into Vancouver. What's the impact of the retreating on this system? We have other works underway, so we're doing this phase 2 study to get our numbers down more succinct, but we're also advancing infrastructure. We have some aging infrastructure, so I can't just ignore the replacement of aging infrastructure because we don't have all the numbers yet. So we're trying to take this into consideration. Our big one are our sea dams. Our sea dams are over 110 years old. They were built by the farmers way back when. There are some cracks in them. And from the study number 1, it says that they are integral to flood protection on our river systems and to the communities upstream on the river system. So we know we have to replace them at some point. They're also none of them seismically stable. So we know any earthquake will probably take them out. So we're now looking at a redesign of them. In the redesign, we're looking at, okay, the gates, we need them down here now, but at sea level rise, I'm going to need my gates up higher. So we've got a system designed to move the gates in time. We've got a system so that when I need my dike to be higher, I'm going to be expanding the parapets. So we're building the base now for the expansion of the parapets, say in 50 to 60 years, to do that extra protection that we will need. These things also have a longer life, but it's just those kind of ideas you're working at. There was some talk also about, we're not doing this alone. There was municipalities, everybody working together. As a regional level, through the Fraser Basin Council, all the municipalities between Hope to Squamish, which is quite a few, and Port Metro Vancouver, Vancouver Airport Authority, 2 railways, I believe CP and CN. I think they were getting hydro involved. We have 5 different ministries at provincial level, Indian and Northern Affairs, we have various Indian bands. We've all come together to do joint projects because we all understand, like Vancouver can do what they want, I can do what I want, but if the pieces in between aren't synchronized, it doesn't matter what we do, the whole economy in the Lower Mainland will crash. We all have got to do it together. We all got to look at where we're vulnerable, and we all got to kind of plan this thing together moving forward on the large scale, not on individual scales, but on the large scale. And so we've got this group formed that I know a few of us are on, and sitting on steering committees with the projects out right now. So we're looking at the risks, the vulnerabilities, and what does the infrastructure in the region look like. And then we're going to try to come up with a regional strategy. All of us have paid a little bit of money into this, and you know, it's kind of the ground up kind of thing as opposed to the top down. And that's it. Questions? Yes.
What's your water supply? Is it vulnerable?
Our water supply, we buy our water from Metro Vancouver. The supply's in the mountains. So they have had problems in the past where they bring the pipes under the Fraser River. At one time, the erosion of the Fraser took out one of the water pipes one time. They've now are tunneling new ones deeper. We do have a backup system we could bring groundwater wells in, is our backup system. So we have it it's not as vulnerable for the flooding, it's more vulnerable from the seismic. So we do have a backup system for that. We're trying to do it in about a 2-year time frame. So we all agreed to chip in so much money year 1 and so much money year 2, and what phase 1 covered and what phase 2 was covered. Us on some of the steering committees, anybody was allowed to be on a steering committee if they chose to. We have 3 steering committees going right now, depending on the project. And we're trying to get the things out. So what you're seeing is the steering committee people off the side of our desk is, okay, who's ever put an RFQ out? Okay, I have, okay, and we're writing those. Okay, who's ever done a terms of reference? We're writing those between our groups on the steering committee. So it's really, and then we're hiring the consultants. So the base money was really to hire the consultants and to pay for the facilitation through Fraser Basin Council. Because they're kind of a nonpartisan group, it doesn't lend us to the same politics. So it allows us to advance the science or to advance the strategy without like really finger pointing too much at this point, and just, you know, propose the facts. It doesn't mean we're ever going to have the money to build this stuff, but we're trying to show the economic value not just from the loss, but for the provincial and the federal economies, and then also how vulnerable we are, like what's the assets we have, and what don't we have, what will we need to adapt. So, anybody else?